Welcome to Unit 2, Lesson 5. Hopefully at the end of this lesson you'll be able to compare quantities between two functions given in different representations. So basically this lesson is just one giant review lesson. So we should be able to keep this video nice and short and sweet. So take a minute and pause this and write everything down and we'll get moving. Alright, so let's start with our think about it question. I think you can do this pretty much on your own. The only thing that's going to be a little bit different for you is that interval notation. You're probably not too familiar with it. We've worked with it a little bit when we had to find the domain and the range for our quadratic functions. We talked about that before. And a little bit, we can talk a little bit about it with respect to end behavior too. The first question, when it says name the interval in which the function is negative, all right, what that's asking me to do is, well, just that, find the interval. So I'm going to look for where my function is below the x-axis. That's where my f of x, my y values down here. Ooh, you can't see that very well. Let's pick a different color. Or my values down here are below the y-axis, the x-axis, all right? So I'm looking for where I'm below the x-axis. So, for example, the answer to number 1 would be, name the interval in which the function is negative. So, that would be negative 2 is less than x is less than negative 1, and 1 is less than x is less than 2. And it says explain. Well, why is that? This is because, so those are my intervals, because this isn't a very well wrote out explanation. I would like a little bit better, maybe. Well, we'll take it. Because f of x is less than 0, right? That means my function is below the x-axis, or my y values are negative, all right? So that's where my y values are negative. So I'd like you to take a minute and pause the video and try these next 4 and name the interval for each one of these. We use inequalities to name the interval, all right? Hopefully we can do that, and if you're a little sketchy, I expect to see you in the morning because this will take 5 seconds to go over really quick. So hopefully we can do that, and we are good. Okay? Moving on. Next, I'd like you to try this problem. All right, it's got a lot of review in here, from all the way back to Algebra 1. So the quadratic polynomial p of x has the following has the following function, has the following form. P of x equals, parentheses, x plus 2, parentheses, we'll just say x plus 2 times x plus 1 times x minus 1. So is that a quartic or a cubic? How many terms? 1, 2, 3. Wow, there's a typo. So that's really not a quartic. So we have a quartic or a cubic. Cubic is 3, right? Length times width times height. So we really have a cubic function here, not a quartic. Quartic is 4. All right, so we have our cubic function, and this is a cubic. This is a typo. So let's fix that. Cubic. Okay? And we have some points here that form a line. Do you remember how to find the equation of a line? Given 2 points, this is strictly a line. It's not there's nothing fancy here. It's just a line. So in order to do that, you need to find your slope, right? You need to know your slope. And slope is what? Slope is delta y over delta x. So that means change in y over change in x. And for those of you that need to remember the formula, that's y2 minus y1 over x2 minus x1. That gives me my slope, and we call that m. And then you have a point, so we can use our point slope form. So that's y minus y1 equals m times x minus x1, where x1 comma y1, that's a point given to me. So that means if I pick any of these points, say this one here because it's easy, and I plug that in to my equation, then that will give me the equation for my line, and then I could answer the question, which function has the larger y-intercept? Because you can put that into y-intercept form, and then you can justify your answer with your algebra and your reasoning skills. So that means maybe you're going to have to multiply this out too, you think. All right? So I'd like you to do that, and I gave you everything you need to get through it. So let's move forward so we can keep this short. All right, the last thing I need you to do, or I'd like you to do, is compare the function of y equals x cubed. So you're going to have to use a computer to graph this, or Siri, I guess. But if you go to Wolfram Alpha, it'll graph it for you as well. And then you can go from there. So, show the function in the graph below, which has the form y equals ax cubed. Which function has a greater vertical stretch factor? Ooh, I'd like to see if you can remember how to tell, or remember what it means to be vertically stretched, okay? And explain your reasoning. So you're going to be looking at the graphs, and you're going to try and figure that out, all right? So that means you're going to need to understand what a vertical stretch and a vertical compression is, all right? So that you can explain what's going on. And if you don't remember, they should be in your notes so you can look them up. All right? So I've done my best to keep this as short as possible for you, and I look forward to seeing you later. Have a good night, guys.